Right, today we got logarithmic functions and graphs. Another thing, hopefully you've seen a little bit of this in algebra 2. If not, we got it. Two hugely important properties. The first one says this is how logs work. Log base a of x equals y. Basically, you do this. You do a to the y power. Let me erase that real quick so I clean it up some. Okay, basically you do a to the y power equals x. Makes like a circle. A to the y power equals x. That's what makes that log true. That log is true if a to the y equals x. Also, because that's the case, a to the 0 is 1. So if you see log of any base right here, base a, base whatever, and there's a 1, it's always going to equal 0 because anything to the 0 power is 1. This one, a to the first power is a. So anytime you see these two numbers here are exactly the same, it's always going to equal 1 because a number to the first power is always itself. Remember, that's how log works. The base to that power equals 1. The base to that power equals that number. A to the y equals x. I'm drawing all over the place. Let's see. Let's work a couple here. Okay. It says find each of the following logarithms. So the first one's basically saying, because the base is 10, 10 to what power is 10,000? And because 10,000 has 4 zeros, it would be 4. So the answer to a log is an exponent. A log is the inverse of an exponential equation or exponent, so the answer is the exponent. So the second one says log base 10 of really 1/100th, and because it's a decimal, which is really a fraction, 0.01 is really 1/100th. What power would you raise 10 to get 100? Well, first of all, you'd raise it to the second power, but because it's been flipped, you would say -2. The answer is the exponent. Third one, log base 5 of 125. It's asking you 5 to what power is 125? The third. Part D, log base 9 of 3. So it's asking you 9 to what power is 3? What power would you raise 9 to get 3? Well, first of all, we know that 9 is the square root of 3. That means it's going to be a fraction exponent like 1/2. Remember, bottom is the root, top is the power. Square root of 9 is 3 to the first power. And finally, this is asking 6 to what power is 1. That's obviously 0 because anything to the 0 power is 1. Hope that slide made some sense. Look at the next one. So it's convert each to a log equation. All right, so basically whatever the base is up here is going to be the base in your log. So I'm going to say log base 2 of 16. Remember, the answer to log is the exponent. You can check it. 2 to the x power equals 16. Okay, look at the next one. I'm going to say log base 10 of 0.001. Remember, the answer, or what it equals, is the exponent. Is 10 to the -3 0.001? Yes, it is. The second part of this slide says convert each to exponential. So I'm going to take the base, 2, raise it to the 5th power, and it should equal 32. You're not trying to find an answer here. They're just making you practice how logs actually work. Part B, a to the 8th power is q. All you do. Okay, just again, making you practice how logs work. Okay, find the following common and natural logs on your calculator. Round to 4 decimal places. All right, so all you have to do is punch those straight in. So what I went ahead and did is I went ahead and punched them in, took a picture of my calculator, and here it is. Log 645,778, punched it in, got 4 decimals. Log, the second one right there. The third one, the part C, I tried to punch that one in. Actually, I didn't because I know it was going to be, but you cannot do a negative log. You cannot have a log of a negative number. And if you do that on your calculator, it's going to give you a big error message. All right. Also, in case you don't know, the log button on your calculator is, you can barely see it on my picture. It's right there though, and the natural log button, the LN button, is right there. So that's where the buttons are, in case you can't find them, which I think you can. Okay, so then it said to do natural log or LN 645, and you can see I did that, and it also said natural log of the second one that we did, 0.000239. So did those and got those answers. Also notice 2 of them were negative. The negative answers were the decimals because they turned into fractions, which means you had to flip the base 10. Oh, should have said this too. Common log means base 10. So notice, if you notice those first 3 up here did not have a base written. If you don't see a base, that's called a common log, which is base 10. Also the second, the D through H problems, there's also no base. If you see a natural log, it's always base E. And if you look at your calculator above, you can barely see it, but above the log, well, you can't see it. But if you look at your calculator, above the log button, it says 10 to the X. Above that natural log button, it says E to the X. And that's why. Okay, the last two I didn't put those in the calculator because you don't need to. Remember, when you see a natural log, it's really base e. So it's asking you e to what power is e? The first power. E to the first power is e. The second one is really asking you base e. E to what power is 1? Well, anything to the 0 power is 1, so it's just 0 right there. All right, change of base. This is pretty handy. If you have a log like this, log base b of m, you can rewrite it and change it to any base you want to, as long as you put log of m over log of b. The base stays on the bottom. And I didn't put a base on there because most of the time when people do this, they change it to base 10 because that's what your calculator knows. So this next problem says find log base 5 of 8 using common or natural logs, because you can't punch in, like, you can't do 5 to some power is 8 and figure that out in your head. So what you do is you change it to base 10. That's what a common log is. And you put log 8 over log 5, and you punch in your calculator. You can also do natural log 8 over natural log 5, and you'll get the exact same answer. You can change it to any base you want to, but the reason we choose either common or natural log is that's what your calculator does. So I'm punching in it right now, log 8 over log 5, and I get 1.2920. You might have punched that in with me. The second one, I'm punching it in also, natural log 8. Make sure you close your parentheses over natural log 5. Got the exact same answer, because it doesn't matter what base you change it to as long as you change it to the same base. And again, these two bases are by far the most popular because your calculator does both of them. No need in changing a base 5 to a base 3 very often, because your calculator doesn't do base 3. And that's all we got for the day. So watch for your assignment on the website and also Google Classroom, and knock that thing out. Please, please, please text me as much as you need to. Email me for help. I want to make sure you get this because we're going to graph this stuff on Monday. I want to make sure you have this down pretty good. So let me know. See ya.